Hello there, this is Amir, and I want to give some example on extracting data from Kaplan-Meier curves to generate hazard ratios so we can enter them in our meta-analysis. So I will use a paper. I will use this paper called Practical Methods for Incorporating Summary Time to Event Data into Meta-Analysis. And believe me, I have gone through so many uh, methods, and this one is the best one, I think. It is so easy to use, and this is one of the best things that you can perform your data extraction on. So it has a Excel sheet attached to it at the end. Here you can find it. Generally, it looks like this. So in my research, I found that I can only use Kaplan-Meier curves that reported numbers at risk at each time point at the bottom of the curve. So there are so many papers out there with poor quality, and I will show you why I'm saying this, that uh, you should not extract hazard ratios from Kaplan-Meiers that uh, didn't report these numbers at risk at the end. So first thing first, you should screen capture this figure, then you should save it, and then you should put it on this website called, I think, webplot digitizer. You will load your data from here. uh, After loading your data and selecting this, the first default option, you should define the axis. You should do this like very precisely. So yeah, and this is the y-axis, and then I will click complete. I will tell this tool that the x-axis is from 0 to 16 and y-axis is from 0 to 1 or 0 to 100 if you are extracting percent, which is the preferred output for us. So then you should label this data in two data sets. The first data set in my case is incidental. The second one, I can add data sets like this. The second one is symptomatic. And I will change the color of this. So, and then I will put points on the lines. So usually I put a piece of paper to perfectly align these time points with the corresponding value. So for example, I did it for this, like this is the incidental ones, and this point presents the value for the data point 12 months, and same goes for 24, 36, 48, and 60 months. So I will do the same for symptomatic. And the thing that I wanted to mention in my case is that the end point is not 60 months. As you can see, it ended like a bit uh, earlier. So you can after that you should click view data, and you should copy and paste these values into your sheet. So this is the first thing that you should do in your extraction, and this is the values for symptomatic. And as you can see, the last this is the x and this is the y of that point, and as you can see, the last month is like 55 or 56, and this is 48, this is 36, 24, 12, and 0. So, and these are the person, and these are the person, and these are actually the I put the axis from 0 to 1 in this case. So let's go to the sheet. So in the sheet, you should put the trial ID, which I put the first author names out there. The name for each arms, in my case, incidental and symptomatic. Randomized ratio, usually this method is used for uh, trials, clinical trials, but I'm extracting data for my and I'm extracting from observational studies. So I put the randomization ratio as the total cohorts, and these are the patients entered in the study. As you can see, are reported here. So actually, there is one individual in the research cohort and two individuals in the control cohort that did not met the inclusion criteria for survival analysis. And again, in my case, it didn't present the actual event rates, but it presented the percentage. So I calculated the percentage by multiplying this percent to the all of the entered patients. So let's move on. This is the sheet that you should work on called 3A. So you will put your time points here, and my last time point would be like 56, I think. Yeah. And here you will define the percentage that you previously collected. So let's see that again. Yeah. Actually, you can copy and copy these things there, but in the percent. Uh, so you should like multiply it by 100. So the first one would be this is 100. This is 96.3234. Like, yeah, this is it, 96.234. And you should enter all of those probabilities here, as I did, with 3 decimal points. At least you should do it with 3 decimal points. And these are the numbers at risk, so in each cohort. And you can get these from this from bottom of the figure. Again, I want to say don't extract data from Kaplan-Meiers that don't present their numbers at risk. I will show you the case, and this case, by extracting data, assuming that I don't have these numbers at risk, and you will see how much different the hazard ratio would be from the actual multivariate one and and my version of extraction. So let's back. Okay, so after entering these number of patients, for example, 55, 46, 37, and here would be 55, 46, 37, and blah, blah, blah. You can see the curve here. Sometimes I double check my points by just placing these figures next to each other. So you can do this on your own. And in the sheet called for output information, you can see that using the 11th method, which is this data from care with numbers at risk given, it will give you hazard and 95% confidence interval, and you can use this for your meta-analysis. Okay, it can actually generate hazard ratio and confidence interval from various methods. For example, if you put in all of these data, if you put expected events, it will generate, I don't know, it will describe it here. Yeah, observed and expected events. It will calculate hazard ratio in this column. And if you report hazard ratio and confidence interval, if you have a paper that presented hazard ratio and confidence interval and you want ln of HR, you can put that there, and you can put that, let me show you here. You can put hazard ratio here, variance, all of these things. If you put these things on your sheet, you can generate different hazard ratios. My recommendation is to extract data from Kaplan-Meier's, which is an indirect method of meta-analysis, and the preferred method is to put reported univariate hazard ratios, and keep in mind that these hazard ratios should have the same type. For example, you can't actually meta-analyze hazard ratios of overall survival with progress-free survival. And that's it. So let me show you the last thing. I also gathered extracted data points. As you can see, it has a automatic it has an automatic extraction tool where you can define the color of the line and put the place of the line, and it will automatically extract these points. So I prepared an Excel file here. I will briefly tell you what you should do. So these are the points from the web digitizer, if I spelled that correctly, and these are from the for incidental cohort, and these are for the symptomatic cohort. Simply you can multiply these to 100 and you can get a percentage. But keep in mind, sometimes these two data points will not be equal in the length. As you can see, yeah, these are the original data, and you should convert them with same number of points. And for this, you can find the slope of the actual points like this. This is the formula, so it's not that hard. You will find the slope and you will find the intercept. And then you can generate new, you can estimate the data points by multiplying the x, in this case months of survival, to the slope, and add the intercept. So you can generate the same number of points for both of the groups. And then you can actually copy this to the sheet named 2A, as it says that here you can put data read from curve where wished. So and I also downsampled these points, and because I can actually put about 30 points here, so I downsampled it to, let me see, yeah, 30 points. I did this randomly, and let's copy these values. Yeah, these are the time points. Am I right? So I paste the time points here, and I pasted the wished values or time points for the incidental cohort here and for symptomatic cohort here. And as you can see, the hazard ratio is 1.2, but here you can see the hazard ratio is 0.37, and the direction of effect is actually at the opposite side. And here we can see the wished method is far different than the previous one. And if you see the tables, yeah, if you see the tables, actually it is so obvious that hazard ratio for incidental should be lower than 1 since they have better survivals, and this is confirmed in the actual multivariate hazard ratios. So yeah, that's it. This is like they performed hazard ratio in a different direction, since the reference group in my case is symptomatic, but here is incidental. So as you can see, if you transform this in the opposite direction, it would be something like 0.25, and this is far more closer to data extracted by uh, giving these formula numbers at risk. So this is the preferred one. That's it. And then you can use these as a ratio and confidence intervals for your meta-analysis. That's it. This is the best method and easiest method, thanks to authors of, let me tell their name, because they really made this easy, and you should also read their paper. There are so many points that you should consider when doing this method, and this is not the preferred method. If you have a sufficient number of studies reporting hazard ratios, you don't need to do this, and this is the indirect estimation of the actual effect. So that's it. Keep safe.